Hello everyone, welcome to my channel Chemistry is Fun. So today we will be continuing with the gaseous state, and in this we will see today the ideal gas equation. Now this ideal gas equation is dependent upon the ideal gas law. We can also call it the general gas equation, and it depends upon a hypothetical ideal gas, and it is the equation of state for a hypothetical ideal gas. So we can approximate the behavior of many gases, but we will find out that there are many limitations to it also. In general, we can say that it's a combination of many laws like Boyle's law, Charles' law, and so on. Now let us see how we arrive at this equation. Now this equation we can obtain by combining Boyle's law and Charles' law. Now we have already seen these two equations, like at constant temperature and definite mass, the volume is inversely proportional to pressure, that is V is directly proportional to 1 by P. This I have told in my earlier videos already. So let this be equation number 1. Another direct proportionality between volume and temperature, V is directly proportional to T. This takes place at constant pressure and a definite mass. Let this be equation number 2. Combining both these equations, we get V is directly proportional to T by P. Or we can say that P by T, PV by T is a constant. We just we can cross multiply. So PV by T is a constant, and this constant equal to R, that is universal gas constant. So PV by T is equal to R, that can be stated as the equation number 3. Now since I am saying that PV by T is constant if there are two conditions, state 1 and state 2, then P1 V1 by T1 will be equal to P2 V2 by T2. So when the pressure, volume and temperature are varied, this relation between pressure, volume and temperature remains constant. So from here what we get, I have already stated, that is equation number 3, PV by T is equal to R, which is a constant. If we just cross multiply here, we get PV equal to RT. This is for 1 mole of a gas. When the number of moles equal to 1, this equation holds good. Now earlier when we introduced R, we know that when we have to remove the proportionality sign, we have to arrive at some or use some constant. So R has been used here. For 1 mole of a gas, PV equal to RT. If there are n moles of gas, n number of moles, then we have to multiply the right hand side with n, because if n number of moles, and if we know 1 mole of a gas value for 1 mole, we just multiply with n. So we get PV equal to nRT. Let this be the equation number 5. Now what is n? How to calculate n? If we know the mass of a gas in grams and the molecular mass of the gas, that is the mass of one molecule of the gas, if we have both the values, if we represent mass of the gas, means given mass of the gas with small w and molecular mass of the gas by capital M, then n equal to number of moles equal to W by M, that is mass of the gas given in grams divided by molecular mass of the gas. This will give us the number of moles equal to n. So putting n equal to W by M in equation number 5, this is equation number 5. In place of this n, we will put W by M. We get PV equal to W by M into RT. So what we get, we are substituting V to the right side, we get P equal to W by M into RT by V. Now we rearrange here. We can do some rearrangement here. So we get it as equal to W by V into RT by M. But we know mass by volume is density. So W by V will give the density. So in place of W by V we write D. And this M we substitute here. So it is D by M into RT. This is equation number 7. So this is the new equation we have arrived at. Now see numerical values of R. Now we know that R equal to PV by T. So using different units we will arrive at different values for R, capital R. So see, we will get R as 0.0821 liter atmosphere per Kelvin per mole. Liter atmosphere per Kelvin per mole, because we know R is equal to PV by T. We put the values of P, V and T respectively. If P we take as 1 atmosphere, volume is taken as 22.4 liters and temperature 273 Kelvin, then the value that we get equal to 0.0821 unit will be liter atmosphere per Kelvin per mole. So using the formula R equal to PV by T and putting the values of pressure, volume and temperature, we get the value of R, that is 0.0821 liter atmosphere per Kelvin per mole. This is one way of finding. Another we can say, if we take pressure as 76 into 13.67 into 981 dyne per centimeter square. Dyne per centimeter square, if this is the pressure, volume is 22,400 milliliter for 1 mole and temperature T is 273 K. Then putting all the values of R, so here also we will get R, you multiply pressure into volume and divide by temperature. Here we get 8.314 into 10 to the power 7 erg per Kelvin per mole. 8.314 into 10 to the power 7 erg per Kelvin per mole. So if you convert it into joule, we get 8.314 joule per Kelvin per mole. So this is another, see, we have changed the unit, so the value of R is also changing. If we put pressure in dyne per centimeter square, value will be different. If we take pressure in atmospheres and volume in liter, then and temperature in Kelvin, temperature is in Kelvin in both the cases, but in the previous case pressure was in atmospheres, so the value is different. Now we will see one or two numericals so that you can understand how to do the numericals. You see, these are very important in physical chemistry. Numericals are a must. So let us look at the first numerical. 3.7 grams of a gas at 25 degrees C occupied the same volume. Same volume of what? Same volume as 0.184 gram of hydrogen at 17 degrees C and at the same pressure. So here what is same? Pressure is same, volume is also same. They have given same volume, they are occupying same volume at the same pressure. Only temperature is different for both. Mass given is also different. What is the molecular mass of the gas? This we have to find out. Now let us see how to approach this numerical. First of all, we will put down the data. For hydrogen, what is the mass given for hydrogen? 0.184. So W is equal to 0.184 grams for hydrogen. Temperature given is 17 degrees C. We have to convert it into Kelvin. So for converting, what we should do? We should add 273. So what we get? 17 plus 273. If we add, how much we will get? 290. 290 Kelvin. M will be equal to 2. Molecule is hydrogen is H2. And we also know PV is equal to nRT. PV is equal to nRT. In place of N we can write W by M. So PV is equal to W by M into RT. We have to put the values. W how much they have given? 0.184. So we write here 0.184 divided by M is 2 into R into 290. 290 is the temperature in Kelvin we just got. For the other unknown gas, if we see, W given is 3.7 grams. T is 25 degrees C. So converting it into Kelvin, add 273. If we add it, we will get 298 K. And we have to find out the M, molecular mass. So M we do not know. That is the unknown quantity we have to find out. Here also, because they are maintaining the same pressure and volume, so PV is equal to, we are keeping the PV same, W by M. So what is W? 3.7 by M into R into temperature 298. Now for both the cases, PV is constant for hydrogen and this gas. So we can equate these two equations. Initially we got that one, PV is this one and this one. We can equate because left hand side is PV for both, which is same. So we write these two together. So what we will get? 3.7 by M. This M is the quantity we have to find out. Into R into 298 is equal to, earlier for hydrogen we got 0.184 by 2 into R into 290. This was the temperature. See, R will get cancelled on both the sides. So what we will get? M as M. We take M here and this full thing 0.184 and 290 will bring to the denominator. R gets cancelled on both the sides. So we get M equal to 3.7 into 298. These 2 will shift there, so into 2 divided by 0.184. This will come, no, this full thing will come to the denominator on the other side, 0.184 into 290. So if we multiply the numerator value, if we multiply, see the top value, it will come to us as 2205.2. You can multiply and see, just simple multiplication. 2205.2 divided by, this is a decimal, 53.36. And when we solve it, we get it as 41.3268. If we round it, this is a decimal. On just we can round it up because it is 3 to 6. So after 2, the digit is 6. So we can round it and we get 41.33. So here the molecular mass of the gas will be 41.33. So this is the way of calculating. So after doing this numerical, I hope you have got a glimpse of how to arrive at the questions. Now one more numerical, it's of a little different flavor. What is the pressure of HCl, hydrogen chloride gas, at minus 40 degrees C if its density is 8 kg per meter cube, 8 kg m to the power minus 3, 8 kg per meter cube. Here R we have to use is 8.314 joule per Kelvin per mole, K to the power minus 1 per Kelvin per mole. This is R value we should use. Now we can use the ideal gas equation. We know PV equal to N means W by M into RT. So this equation we have to use. Now here we can substitute V, then it will become P equal to W by M into RT by V. Okay, we can rearrange, so we get W by V into RT by M. But W by V, what is W by V? Mass by volume, density. So it is density. So this part, this W by V part, it becomes D into RT by M. D into RT by M. Now here density value they have given. We can put the values. P equal to density, how much they have given? 8. So for density, in place of density we can write 8.0 into R value they have given 8.314. We will put it up into temperature, how much they have given? Minus 40 degree. So T equal to minus 40 is given. What we should do? Add 273. So it is minus 40 plus 273. So we will get how much? 233 Kelvin. We are converting to Kelvin. 233 K. So that we will write here 233 in place of T divided by M. So M is 36.5 because it is HCl. HCl, hydrogen chloride. For chlorine it is 35.5, hydrogen is 1. So altogether we get M as 36.5 grams per mole. So in place of M, what will be M for HCl? 36.5 gram per mole, because HCl I told you, we can calculate the molecular formula. Hydrogen is 1, chlorine is 35.5. We add, we get 36.5. It will be in grams per mole. We have to convert it into kg. So what we will get? Because density is in kg per meter cube, so we have to convert it into kg. So multiply by 10 to the power minus 3. So that is equal to 36.5 into 10 to the power minus 3 kg per mole. So we can put this value in place of M. So we get 36.5 into 10 to the power minus 3. Now when we calculate, if we multiply the numerator, all the three values, what we get is 15497.296. See, I am not showing the calculation part because multiplication we all know. You just simply multiply the numbers, that's all. And denominator is 36.5 into 10 to the power minus 3. On calculating all this, finally we get 424.583. 424.583 we can just can omit also, into 10 to the power 3 Pascal. 424.58 into 10 to the power 3 Pascal. So we have calculated two numericals. In my coming videos, wherever possible, I will include such numericals for better clarity. I hope you all could understand the topic which I discussed today. Please subscribe to my channel. Thanks for watching the video. Please subscribe to the channel. Thank you all. Thank you.